Okay, we talked about frequency table, and the frequency table is right here. Green. Let's change that. There we go. There's two types of frequency tables. There's qualitative and the what? Quantitative. Quantitative. Okay, quantity has to do with numbers. Quality has to do with categories. In this case, not numbers. These are categories. Why are they categories? Because they describe something. They describe the score of 90 to 100, 80 to 89, 70 to 79, 60 to 69, and failure. Okay? If I wanted to have, this would be qualitative data. Quantitative data would be 18 to 24. Okay. How did I do that? Okay, whatever. 21 to 24, 3. 24, 25 to 27, 8. Okay, I'm just making those up. Thank you. What did she say?
Work.
What?
She said they should work.
Oh, thank you. All right. Again, this is a class. Class is usually given by what? Numbers. And of course, this is the head count. The right side is always the what? The head count. Unless you hold your pinky up and then you call it frequency. Head count and frequency is the same thing. All right. How many blinds do I have in here? Let's go with something else. How many A's I got in here? 4. How many B's? 7. This is how many students, head count. So the frequency and the head count is the same thing. Okay? As it says, the first column is either the categories or the class. This is categories. Categories go with qualitative. Class goes with quantitative. Capiche?
Wait, what?
Uh-huh.
Okay, so quantitative.
It's classes. Numerical.
Okay, and qualitative is
Categories. Blonde, brunette, redhead. Blue eyes, brown eyes, green eyes. Okay? Don't interrupt class no more. Now, who you think you are? Gosh. Relative frequency. Relative frequency is a 25-cent word for percentage. All right? Let's say that we have A's 4, B's 8, C's 12, D's 7, F's 3. What is N? So add them up. Well, 12 and 8 is 20. 7 and 3 is 10, so that's 31. 34. Somebody check me. What you got? Add them up. See what you get. So N is equal to 34. N is always going to be your total. It's always going to be your summation. It's always going to be your big number. Okay, write those 3 things down. N is always going to be your total. N is always going to be your summation. And N is always usually going to be your biggest number. So if I want the relative frequency for each one of these, that would be 4 over 34. Or somebody give me that decimal. What's 4 divided by 34?
.11, you want me to round it?
Just, yeah, to 2 decimals.
.12.
Or 12 what? All of that is what we call the relative frequency. You have to read the directions to see which one they want, whether they want a fraction, a decimal, or a percent. Don't let the frequency distribution, don't let the relative frequency, don't let the BA words confuse you. Okay? A relative frequency is nothing but what? Percentage. Okay? Really don't need to see there.
How many decimals is it?
They'll tell you. I just do 2 because we live in a world that everything's around dollars and cents. So I round everything to 2 digits because that's what everybody's used to, dollars and cents. So let's do 8. Do all of these. 8 over 34, 12 over 34, 7 over 34. Do this in your notes. 3 over 34. Change it to a decimal and change it to a percent. Do that in your notes so you'll have it. No coughing in class. Can't cough, can't yawn, and can't sneeze. Now, look at the bottom. It's going into cumulative frequency, which is just about worthless. Now, I want you to see the cumulative frequency, and I want you to see how they get it. How do you get the first cumulative frequency? Well, the first cumulative frequency is the head count of the first category. And then you add the second category, you add the third category, the fourth category, the fifth category. And after you add the fifth category, you should get N. And it is totally worthless. But you're going to have some homework problems that say find the cumulative frequency, and you need to know how to find it. That's how you find it. You take the first head count, and you add the second, and the third, and the fourth, and the fifth, and when you get to the bottom, you should equal N. Now, we spoke a little bit about qualitative data and quantitative data. That's at the bottom right there. Make sure you write it down. Quality, not quantity. Quality means characteristics of. So if I say blondes, brunettes, and redheads, that is the characteristics of the class. If I say brown eyes, blue eyes, green eyes, hazel eyes, that is the characteristics of the class. If I say average weight of the class, that's quantitative, meaning that there is a value to the numbers. What about if I get your Social Security numbers, which is illegal, but if I get your Social Security numbers and put them in order, does that mean anything? No. Social Security numbers is another form of your name, pretty much. It's an assigned name to you from the federal government. Does it have any quantitative value? None whatsoever. It is merely a name. It's a numerical name. Question, gripe, complaint. Next page. Again, this is all reading, so this is a lot of stuff you should already have read or reading right now. Bar graphs and pie charts. Now, I kind of put y'all on autopilot with this because I don't want to insult your intelligence by saying, okay, boys and girls, this is a bar graph. This is a pie chart. I'm not going to do that, okay? Now, if you send me a homework question and say, Hubert, could you go over this? I'll be glad to go over it. But I don't want to insult your intelligence by saying, okay, let's talk about the difference between a pie chart and a bar graph. I'm not going to do that. Now, I will tell you that there are two types of bar graphs. There's the bar graph that you see right there, and then there's called a histogram. Can anybody in here tell me the difference between a histogram and a bar graph?
Histogram, like all the bars that touch each other.
God, I'm just amazed. You are so smart. Because not a lot of people can tell you that. Histogram versus bar chart. I was hoping to pull up a picture. There we go. That's why I use images a lot. There is a bar chart, and there is a histogram. Are we talking stopping the earth from revolving? The difference between the two? No. In fact, half the stuff I think that are in statistics is made up by people that wanted to be mathematicians but didn't become mathematicians. Because if you ever heard a person call themselves a statistician, they made that word up, okay? A statistician is somebody who studies statistics but don't have a math degree, okay? You meet these people, you know. People that call themselves engineers and they're not an engineer, they're like in a category below an engineer, like apprenticeship or technician, but they call themselves engineers. Oh, that griped me. Griped my daddy. My daddy hated that. He would confront people. My dad was very what do you call it? Confrontational. For our preacher, this is awful. I'm going to talk about my dad. My dad was a preacher too. Of course, I'm a preacher's boy, and he would talk to this other preacher. He was talking to this other preacher at a meeting, and I was there. I was there doing something. I can't remember what I was doing, picking up beer cans or whatever. And he asked this preacher. He said, "What are you doing? What do you do for a living when you're not preaching?" And he said, "Oh, I'm an engineer." And he said, "Oh, you're an engineer. What field?" "Oh, well, I draw a lot of drawings." Well, he was a draftsman, okay? A draftsman is not an engineer. So my dad started pushing, started prodding. Yeah, he said, "Well, it's not. You don't take the classes. You don't do the stress test. You don't do the, tensile test, tensile strength of a beam. You don't do that. Thermodynamics and the dynamics and the statics. You don't do all that." So he said, "Well, what engineering school did you go to?" And by the time he got through, my dad pretty much said, "Don't call yourself an engineer if you're not an engineer." And I don't blame him. That'd be like calling yourself a doctor if you're a nurse. You're not a doctor. Okay? Why do people do that? I don't know. I think it's something to do with their self-esteem. I think. Yeah. If you say draftsman, you don't look as good as, "Oh, I'm an engineer." Yeah. What? I can't believe she just said that. No. Anyway, you see that there's not a big difference between these two. All right? There's not a big difference. Do I really care if you know the difference? No, I don't, because it's stupid. All right? It's almost like, well, we don't have enough to do in statics, so we're going to make up stuff so we can have the students learn more. There is no reason for this.
Is that really the only reason they're different?
That's the only reason. It's the only reason. There's a lot of things like this in statistics, and it's just like redundancy. But anyway, do I test you on this? No, I do not. So But do you need to know it for standardized testing? Yes. Whether you're going into a nursing test, or you're going into a Michelin test, a Bosch test, or if you're doing a GRE to go to grad school, or if you're just doing a placement test to get into another college. Okay? That type question will be on there. Do I want you to know how to do a pie chart? Yes, yes, yes. How to construct one? No. How to calculate? Yes. Let's say, let me give you an example right here of this guy right here. Let's say that you had this on the test, my test or homework, and I said that this is rent, and this is utilities, and this is fuel, and this is food, and this is going out. Okay? And let's say that you make $1,000 a month. And I'm just using 1,000 for easy math. Then I want you to calculate how much do you spend on rent. So tell me how much. $360 a month. That's how I want you to be able to read it. Now you could do get your calculators out. Let's change 1,000 to something more realistic, like $896.32. Now what? Now what would you do? You would take $893.32 and multiply it by point what? Yes, 36.36. And what would that come out to be?
$322.68.
Yeah. My mortgage, I don't even want to talk about my mortgage. By the time I pay my mortgage, my alimony, my child support, my utilities, I got to sell a steer. Pretty much. Tell you what. Will I do it again? Hell to the yeah. In a heartbeat. I'd do it again.
Do what?
Divorce. Huh? How old are you? How old are you? 22. Wait till another 20 years to get married. Guys should not get married. It should be an amendment to the Constitution. Guys should not get married till they're 40 years old. Why? Because they're just as mature as a 25-year-old woman. Most, I'd say probably 80%, or but you still got 40-year-olds that cruise the mall. So you're pretty sad.
It's always that way.
Yep, they're always. You got the 40-year-olds that cruise the mall. So I got somebody I went to high school with still thinks he's a teenager.
Make a bar graph on this.
Yeah, let's don't. Anyway, let's move on. Let's not get on that subject because it's very depressing. Yeah, you shouldn't get married till you're 40 at least. Okay, that's all that. I want you to know how to do a bar graph, so write that down. I mean, a pie chart. I could care less about this. The only thing I want you to be able to do with a histogram or a bar chart is be able to give me a total of how many are being. So here, I've got 4. Here, I've got 4. Here, I've got 7. Here, I've got 9. Here, I've got 3. Here, I've got 2. So what do you do with all those? Add them up. That's right. 11 and 9, 25. So N is equal to 25. That's about all I want you to do with a bar chart or a histogram. Be able to tell me how much is in the total. But make sure you can calculate with a pie chart, because that is not only a standardized test question, that is also a test question in my book. There's another bar chart. If I ask you if 1,500 people are surveyed, How many of 1,500 people are independent? 750, because 50%. You can make, and I will show you how to do this when we get to Excel. We will use Excel. Will we use Excel because you have to use Excel, or do I use Excel because it gets everything on the board? I use it because it gets everything on the board so you can see it. So please don't put on the evaluation and go to my department head and say, he's making us use Excel. I ain't making you do anything, okay? I'm using it because it gets everything on the screen because I write big, okay? So we will use that when we get to it. And I'll show you how to do bar graphs. I'll show you how to do pie charts and all that stuff. I'm sorry, histograms. As soon as I get something important, I'll tell you. And that's 5C. What does the outline say we go to next? 6 or 5D?
5E.
5E. What page is that on? Anybody know? I do not like this new format. Huh? Yeah, you can't type in the page. You used to be able to hit the block and type in the page and go right to the page.
Keep scrolling down.
Huh?
Either that or like just keep scrolling.
3 what? This is so annoying. Oh, the heck with this. I'm going to get out of this and go to 5D or E?
E.
E is an echo. And wait 15 minutes. This is probably where we're going to start getting into a little bit of math. I don't know if it ever comes up. Okay, this is a good subject. Okay, correlation and causality. What the heck is this? Well, it's a very good. I'm gonna kind of break away right quick, and we're gonna go into a little bit of algebra here, a little bit of pre-algebra, and actually I'm gonna just try to impress you. That's what I'm trying to do. But I don't know that's not working out. No, I'm pre-algebra. You remember back in graphing where you learned how to do the slope with line and stuff like that? All right, well, the slope is kind of like correlation. Slope, back a long time ago, was called what? M. And to calculate M, delta Y over delta X, which means the change in Y over the change in X. X of 2 minus X of 1. So if you're given 2 points, 5, 5, 8, and 10. Then you read from left to right, X of 1, Y of 1, X of 2, Y of 2, and you plug in what? Plug and chug. Y sub 2 is 10 minus 5 over 8 minus 5. So my slope is equal to 5 what? 5/3. Comprende? Now, there's 3 types of slope. There's positive slope, which goes left to right up. There's negative slope that goes what? Left to right down. And then there's a horizontal line, which means what? Zero slope or no slope. Correlation is the same way. Positive slope, left to right up. Negative slope, left to right down. Horizontal line means no correlation. Y'all remember doing this?
Yes.
Okay, so let's talk about correlation. What is correlation? This is Hubertism, okay? Correlation is basically a viewable pattern. A viewable pattern. What do you mean a viewable pattern? Well, let's say we're doing the popularity of movies. This is popularity of movies, and this is the cost of movies. Okay, and you got a bunch of points. These are movies in the last year, or whatever. Okay, you got a bunch of movies, like 30 or 40 movies there. Okay, the first thing you look for is a tendency. Do you see where that's kind of moving left to right up like that? Okay, that's what correlation is. Correlation is a viewable pattern. A viewable increase or a viewable decrease or none. Okay? Now, write this down, and this is very important. Correlation does not equal causality. What is causality? Causality, I drink too much wine, I have to pee. It comes from the Matrix. Matrix 2, the second movie. You know when they go to the restaurant? They have a chocolate cake. Chocolate cheesecake, actually. Anyway, and the guy, he's talking French, and he's talking all like this, and he says, I drink too much wine, I have to pee. That's causality. Causality. One causes what? The other. Okay? Let's say that I take the data from Anderson Amstar 14 Theater, and I take the data on, let's see, who's a real bad actor? Nicolas Cage.
I was just.
Okay? Nicolas Cage.
I didn't want to say.
All right?
It's a legend.
He's a what?
It's a legend.
Someone will get offended if you, I knew someone.
Yeah.
I'm not offended by it. No, by no means.
Nicolas Cage.
It's not like he's my favorite actor.
He's just one of those
You gotta
people.
respect.
He's one of those people that out there floating. He's weird.
Hey,
Only
what's
thing
the
I like
movie
is
that
Netflix.
said-
Face Off.
That's all it's.
With John Travolta, which
60
is
seconds.
not in the same category. John Travolta is like the greatest villain you could have is John Travolta.
Is he a national treasure or?
Yeah, National Treasure.
You
yeah.
know that things like, it's good to take the
In real life, he's a pretty space cadet. In real life, you may see him walking around Hollywood in a toga or something. He's really out there. Anyway, eccentric. He's very eccentric. How about
Oh, yeah, I know.
that? Okay. I go to Amstar 14 Theater, and I talk to the manager, and I say, I want to see the movies and the attendance of Nicolas Cage films this last week. And then I put that data with the number of suicides in Anderson County. And I see this. There's correlation, but did those movies have anything to do with somebody committing suicide? No. That's a prime example of correlation, but no causality. I drink too much wine, I have to pee. Now, I know that's something you don't think about, but some people, when you drink too much water, you have to go to the restroom. When you drink too much beer, you have to go to the restroom. The whole point is, that's causality. The more beer you drink, the more trips you make. There's a correlation and causality. The best causality I can think of, the bigger your truck, isn't that Cadillac out there? All right? The less on what? Gas mileage. The lighter your car, the better gas mileage you get. That's correlation and causality. Remember, correlation can be there, but just because it correlates does not mean it what? It causes. Doesn't mean causality. Correlation does not equal causality. You need to write that down because that is true in any of your, what is it, philosophy? I teach philosophy. Okay? Philosophy, that's going to be in your philosophy courses. It's going to be in your marketing courses, in your business courses, and your math courses. All right? Now, what about chemistry and physics? Yes, all of those. All right? If you are taking bacteria samples in a pond. This is biology. Okay? And you see an increase of bacteria or a decrease in bacteria, then there's something, what? Causing. And you have to find the causality. Okay? You ever seen Shark Week?
Yes.
I watch it. Me and my son watch Shark Week at least for the last 11 years. Him and I have watched. Okay, we love Shark Week. And one of the shows that came on was the increase of shark attacks in certain areas around the world. And they would bring in these scientists, and what they needed to find, yes, the correlation is going up, but what is what? What's causing it? This is no joke. One of the instances, there were these tribes, and this might have been in Africa or South America, one of these, not third world countries, but they still have tribes of people that were worshiping, and they would take these dead animals and sacrifice them to the ocean. Chickens, lions, tigers, bears, oh my. I mean, anything they get their hands on. What's that going to do to the shark? It's going to attract them. The blood is going to attract them. Billy Bob goes down to a vacation spot 2 miles down and goes out and chomp, 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 he's gone. Why? Because these people throwing dead chickens out in the daggum water. Another instance was this is again third world country. This would never happen in the United States, not with DHEC or EPA. But a meat processing plant decided to open up a meat processing plant, or meat processing company decided to open about a half mile off the ocean path or the coast. But a lot of drainage and a lot of that wasn't contained pushed all the drainage and the stormwater, pushed all the blood and guts or byproducts of blood and guts into the ocean. A mile down the road, there is a beach spot, public beach. Chomp, chomp, chomp. 3 or 4 people get killed. That causes correlation. Causality, they found, was the meat processing plant. Okay, so you're not going to get out of seeing causality and correlation in pretty much any of the sciences. You're going to see it in marketing. You're going to see it in business. Heck, you'll even see it in the health field. What's making all these people die? Yeah, I mean, if you have a lot of people, where do you see it in the hospital a lot? Some of you may know this. The PV, what is it called when you have babies? Pediatrics? What is it called? What floor is it called?
It's the
Labor and delivery. Okay?
Yeah.
Labor and delivery. Those nurses, they get a kick out of some of the correlation of the moon. When there's a full moon, they will actually, some of the nurses, I've met a few nurses that work on those floors, and they will have charts about when the full moon is, and they'll write down how many births they have, just to see the correlation and the causality of the moon being full versus the number of births, male, female, whatever. They chart how many males are born in December, how many males and females are born in, and then they do a chart on the months, and they try to predict for the next month how many males are going to be born. They do that kind of stuff on these floors. Causality and correlation. They may do it for fun, but the whole point is, this is very true. You cannot say that this is because of this all the time. Some of the time you can. Okay, so know the difference between correlation and causality. Causality, something is causing it. Correlation is just there is a pattern. There's 2 different things there. Okay? You feel good about yourself? Good. Don't need no smokestacks on your truck. I'm going to go get some on my redneck Cadillac. Because I feel bad about myself.
I think I'm gonna give you a big spoiler.
Yeah, get you a 1978 Honda Accord and put rims on it and put $20,000 worth of video and audio equipment in it.
I saw one that was really just like mine earlier coming down the road. It was like bright orange with a huge spoiler and a light.
There you go. That's what you need.
I was like, I think I need it.
Females, when you see one like that, run. Run as fast as you can. Because you're talking about later down the road, probably domestic problems. All right, like the guy that killed his wife because he came home and she didn't have food for him, and she went out and got a pizza. When she came home, he killed her because she went out and got pizza for the kids. He didn't have him supper ready, so she killed him. So he killed her. Yeah, those are the kinds when you nail sunglasses in the gym, run. Run as fast as you can. Oh, I got a whole list of indicators. One of these days I'm going to write a book, and it's going to be called When to Run. That's what it's going to be called, When to Run. When you see one of these indicators, run like... Guys, you only got to worry about Oompa Loompas. That's all you got to worry about. You stay away from the Oompa Loompas. If you stay away from the Oompa Loompas, you'll be all right. Girls, you got to worry about the sunglasses inside. You got to worry about the smokestacks on the truck. You got to worry about the $10,000 worth of video and audio and tires on a $1,000 car. Now, is the '69 Camaro? That's good. 55 Chevy. That's good. Dodge Charger. That's good. You know, you got some cars that you have to kind of put something in. But when it takes the mortgage and everything the person's got, that's a little bit excessive. You got to watch for stuff like that. It's an indicator. All the psychology courses you can take, especially if you're young. Take every one you can, especially at normal. Because you're going to have two things. You're going to go into the job market and you're going to go into the relationships. The more psychology you have, the better. Because you can tell when somebody is totally screwed up. NBS, yeah. Look here. Is there a correlation? Yes. How? How do you know? Because if I just X that one out, and X that one out, and X that one out, why am I Xing out those? Because they're kind of what? You said a while ago. What are they? They're outliers. That leaves you with this bunch. Is there a correlation? Yes. There is a correlation. Okay, because you see an upward what? You see an upward, you can't say, oh, like that. You can't do that. Because there's some down here, and there's some up here. It's going like this. And then you factor in these three. Yes, there is a correlation. All right. Then here's the types of correlation. We've already covered that, but you can look at them. There's another positive correlation right here. See the way it's going up? This is a what? Negative correlation. And there's the three right there, 3 or 4. There, what kind of correlation is that? 0 correlation. Because there is no tendency of left to right up or left to right down. Here's left to right up. Here's left, well, I can't see that one, but that one looks like it's, the way, what I see, it looks left to right up also. So as long as you can see the pattern, you can see the correlation. Whether it's a causality or not, that depends on what you're reading. The question that you're reading. Yeah, those both look to be positive. Question, gripe, complaint. The correlation may be a coincidence. Both variables might be directly influenced by some common underlying cause. Again, yes, when you start talking about there's an increase in crime when there's an increase in pickpocketing when there's concerts at the Anderson Civic Center. Okay? Or you could say there's more crashes when there's an increase in pickpockets. There's more car crashes when there's an increase in pickpockets and there's a concert at the Civic Center. There's an underline there because there's a lot of people in a small place. So yes, you're going to have one or two things happening there. So you have an underline. One of the correlated variables may actually be a cause of the other. And the best one to remember is the weight of your vehicle versus your gas mileage. All right? How to get rich in the stock market. You read this, you'll be rich. Okay? I'm not even going to touch that. Cell phones and distracted driving. You think there's a causality there? Yeah. And that's 5E. Question, gripe, complaint. Now, what I want you to work on is all Chapter 5 homework. Work on all the